Okay, so in this video, I am going to be going over a little bit of detail on the new photometry enhancements that are now available in this new version of Tycho. This will include the new Lightcurve database module, as well as the ability to easily adjust magnitude offsets from one photometry set to the next. So photometry is a wonderful field. You can learn a lot about asteroids just by measuring their brightness over time. So anything that can improve on that process is really helpful. So to get started, let's first go to the Tools menu, and from here you can notice the addition of a new menu item. This is the new Lightcurve database module. So if we choose that item, it will present with a new window, and this actually replaces the old AlcDef search module. So some of you might be familiar with that. You would go to the File menu, Photometry Analysis, and then you would choose Search AlcDef database. Well, that has now been replaced, and it's been simplified. I just now call it a Lightcurve database module, and it's also this new module is a lot more reliable. It's also faster and easier to use. So this is just all around a much improved module to work with. So again, two ways to access it: either the old way of going to File, Photometry Analysis, and then choosing Search Lightcurve database, or more directly, just go to the Tools menu and choose Lightcurve database. So either approach will work just fine. So once you are here at this window, you can search on a large number of objects. So as an example, if I leave the search field blank and click the search button, I'll give it a moment here to refresh the display, but you'll notice it comes back with every single possible object in the database. So if we scroll to the bottom of the list here, you'll notice that it comes back with 35,297 records returned. Now, not all of these will have a Lightcurve available. You can notice that by the numLC column. So this stands for number of Lightcurves available. Now, if you wanted to apply a filter, you could do so. So if I check the box here, I could say that it has to have a minimum of one Lightcurve available. So if I update the listing here, click search, then it will only return records that have at least one Lightcurve that we can work with. Now, even if they do not have a Lightcurve, you could still make use of these other characteristics that are available, the H value, the G value, period, and so forth. But again, lots of information here that you can work with. So even with that filter applied, we still have 22,980 records that have at least one available Lightcurve. Also, what you can do is you can sort these columns. So if I wanted to, I could sort by period. So this is the rotation period of the asteroid in hours. And you can see that we have quite a distribution here of quite a wide range of rotation periods. As another example, I could also just put a filter on that. So maybe I want to work with only asteroids that have a rotation period between 2 and 4 hours. So if I click on search, then it comes back with 3,368 asteroids that have a rotation period between 2 and 4 hours, and that also have at least one Lightcurve available. So lots of options here. As you can see, it's very quick, it's very easy to use, and it's also pretty reliable. So what I'd like to do now is I'm going to work with an asteroid that I've already had some experience with before. So if I type in 1884, that is the asteroid number. So I click search. Now you'll notice it comes back with two results. That's because both have 1884 in the number. So that's where this comes into play, this checkbox. You can search on whole word only. And here it comes back with just that asteroid that had only 1884 exactly as the number. So this is asteroid number 1884, also known as Skip. And you can see that it has 5 Lightcurves available. So if I click on the record here, you'll notice that the import button is now enabled. So if you want to work with the Lightcurves, you have to first select the record and then click on import object. So once you do that, now you have all of that data available. So it has now populated the photometry set window. So these are all of the photometry sets where each set corresponds to a Lightcurve. just to use that terminology. So again, you'll notice 5 light curves were available for this object, and here we have 5 photometry sets have been populated. Now, just to get started, we can populate this graph. We can plot all sets. So this gives us something to work with. And this is, again, 1, 2, 3, 4, 5. So we've got, again, 5 different light curves are shown in this raw plot. Now, if your title does not match this, you can go to the graph menu here and you can type in a custom object label. So again, you can do skip 1884 or give it whatever title you want. Or you could also just choose this option here, use the label from the photometry set. So either approach will work, but if you use the custom label, you'll have to keep in mind that if you work with a different object, you might have to adjust the title each time. So at this point, we now have, again, this is just the raw data, but we've not yet applied any information about our object. In other words, a lot of these columns are blank. So if you look at the photometry measurements, absolute magnitude, for example, that is blank. So in order to populate these columns, we want to apply object data. So the way that works is you just simply select all of the photometry sets, and from the pull-down menu, choose Apply Object Data. So that then gives you a new window here, and you can search by object number, object name, and once you do that, then you can select the item here. Now this pertains to already known objects. More than likely, the object you care about is already known, but if it were not, then you could just apply it from observations of that object. So maybe it's a newly discovered object and you have those observations, you could work with it in that fashion. But for now, this is a known object, so we can apply from selected object here, click OK. So I'll give it a moment here and you'll notice that now these columns have now been populated. And what this allows us to do is we can go back to the graph menu here, plot all sets, and the light curve window now has these options applied by default. So light time correction is now checked by default, as well as H-G correction. So that's the absolute magnitude is now available. So it knows these other characteristics of the object, so it can now apply these corrections. So that's a good starting point. And if I wanted to, I could go ahead and try to determine its rotation period. Again, just using this raw data here with these corrections applied. So I could go to period, find period, and this presents a search window. So I could do a start and a stop. So this would be a search range. So lower bound of 0.5 hours and an upper bound of 12 hours. So if I click on find period, this may or may not find the correct period right off. Again, I've not done any other corrections, but as you might imagine, I'm going to show what that looks like in just a moment. So let's go ahead and do find period, and this presents a period list. So the first period it came back with was 5.79, and the second was 2.89, and these are in hours. So there's actually a PDF document on this object, so we can kind of see what results they came back with. So this was an observing campaign from 2017 to 2018, and they had they identified a rotation period of 2.89484 hours. And if you read the document more closely, you'll notice that the period analysis using the total combined data set yields a period spectrum with several prominent harmonically related solutions, of which 2.89 and 5.79 hours are the most distinguished. So that actually coincides quite well with our period list here. So we had 5.79 was the first result, followed by 2.89. So this is a good first step, but as you look at the phase plot here, this looks like we could do, we could improve upon that. So let's go back to the raw plot here, and that's what I wanted to talk about, was the other enhancement with this new version of Tycho is you can now easily adjust the magnitude offsets from one photometry set to the next. So the way this works is you drag a rectangle around your desired data points, and then they become highlighted, and you can then choose to right click in this window here and then do an offset adjustment. So you could do apply positive 0.1, apply negative 0.1, apply positive 0.01, negative 0.01, positive 0.001, or negative 0.001. So whatever granularity you want. Or you could also do it from the keyboard. So I like to do it from the keyboard. To me, that's just a lot easier. So you can use the up and down arrow keys as well as a modifier. You could do up arrow key with shift, down arrow key with shift, or use the control key. So let's go ahead and take a look at that. So I'm going to do the up arrow key with no modifier, and you can see that that makes a big adjustment. That's the 0.1 magnitude offset. But if I hold down the shift key, you'll notice that it's a much more granular adjustment. And of course, if I do the control key, then it's another factor of 10 more granular. So let's go ahead and try this with the other photometry sets here. So I'm just going to try to line these up, and this one over here. Now, if you happen to have two photometry sets that are really close to each other and you are having difficulty selecting the data points of just one of those two sets, then what you can do is use the markers on this horizontal axis to more or less zoom in on that desired photometry set. So in one example here, these two photometry sets are really close to each other. So let's say that we wanted to just focus in on that left photometry set here. Well, I can take this marker on the right and adjust its placement, and that starts to more or less zoom in on this region. And I can take the marker on the left and adjust its placement, and now we can start to see how this works. You can start to zoom in on whichever photometry set you want to work with. So again, if I want the one on the left, then I can adjust the markers as follows. And once I have it in view, then again I can drag my rectangle over that photometry set, and it will select all of its data points. And of course, as before, I can then apply my magnitude offset or do whatever I want to with it. So to get back, just go ahead and move these markers back to the ends, and you're back to where you started. And this is a good, just about a good alignment. So let's go ahead and try to do the period search once again. So I'm going to do another period search, this time with having adjusted the magnitude offsets. And so let's go back to this window, find period, and now you can see this looks much cleaner. So this looks much better for the phase plot, and it really matches what they had in this document quite well. So this is what they show on their plot. And we could also kind of achieve that same visual style if we wanted to. We could do a classic style, so you can kind of differentiate from one photometry set to the other by using different shapes and colors. You could also adjust those plot sizes, so that might help you to see it better. Again, lots of different ways to customize it. I'm not going to go into all the detail on this video, but this is, again, a starting point. So here again, we have the period list, and as it turns out, having made those offset adjustments, we now have 2.894875 as the top result. And again, if we go back to what they found, they had 2.89484. So this is a very good result. It matches theirs quite well. So again, this video, mainly I just wanted to show that we now have a new Lightcurve database module, and we now also have the ability to easily adjust magnitude offsets from one photometry set to the next. So I hope you enjoyed this video. Thank you for watching, and see you next time.